Hey guys, I just wanted to record a quick video to show you a quick review of everything that we've learned about quadrilaterals in this chapter, Unit 4A. So follow along with me if you'd like to learn more. So first of all, quadrilaterals. What we talked about for quadrilaterals, these are shapes with four sides. In all quadrilaterals, the interior angles have a sum of 360 degrees. Okay, the first type of quadrilateral special type that we talked about are called parallelograms. Parallelograms are shapes that look like this. Here's what's special about them. They are quadrilaterals with opposite sides parallel. We can prove this on a coordinate plane by using slope formula. Remember, if the slope of two lines is the same, that means that they're parallel. So if you check the opposite sides in the shape and they have the same slope, that means that the opposite sides are parallel, which means that it's a parallelogram. Okay, so that's the definition. Here are some properties of parallelograms. First, we know that the opposite sides are congruent. This can be used to prove that a shape is a parallelogram by using distance formula. If you check if the opposite sides are the same length, that will show you whether the opposite sides are congruent or not. We also know that the opposite angles are congruent. We know that consecutive angles are supplementary. Remember, that means they add up to 180. We know that if there is one right angle, there is automatically four right angles. And finally, one other property is that the diagonals bisect one another. This can be used to prove that a shape is a parallelogram by using midpoint formula on a coordinate plane. One other way to show that a quadrilateral is a parallelogram is to show that one pair of opposite sides is both parallel and congruent. So in order to do this, you would have to do slope formula and distance formula on just one pair of opposite sides. So there's everything we know about parallelograms. Now we learned a few specific types of parallelograms. First, we learned about rectangles. Rectangles are parallelograms that have four right angles. So since they're parallelograms, They have all of these properties of parallelograms. Remember, this symbol means parallelograms. Some additional properties that apply is that all the angles are right angles. And the diagonals are congruent. This can be used to prove that a parallelogram is a rectangle. Once you know that a shape is a parallelogram, you can prove that it's a rectangle by showing that there are 4 right angles. This can be done by using slope formula. Remember, if the slopes of 2 lines are opposite reciprocals, that means that the lines must be perpendicular. Therefore, they would make a right angle. You can show that the diagonals are congruent by using distance formula. You would show that the diagonals have the same length. Then you would be able to conclude that it's a rectangle. Okay, next we learned about rhombi. A rhombus is a parallelogram that has all 4 sides the same length. So all the properties of parallelograms still apply because it is a type of parallelogram. So all of these properties above for parallelograms apply to rhombus. But they also have these additional properties. All sides are congruent. All 4 sides. The diagonals are perpendicular. And the diagonals bisect opposite angles. In order to prove that a shape is a rhombus on a coordinate plane, the first thing you need to do is to check if it's a parallelogram. Once you know it's a parallelogram, you could check if all the sides are congruent by using distance formula. You would technically only need to check the distance of 2 consecutive sides because based on the fact that it's a parallelogram, you will already know that the opposite sides are congruent. So you just need to check if a pair of consecutive sides are congruent. You could check if the diagonals are perpendicular by using slope formula. Again, just to reiterate, if the slopes of 2 lines are opposite reciprocals, remember that means it's negative and it's 1 over the number, then that means that the 2 lines are perpendicular, which means that they form a right angle. So those are the properties of rhombi. Next, we learned about squares. Squares are combinations of rectangles and rhombi. So a square has all the properties of parallelograms, rectangles, and rhombi. So all of these properties that we've listed, all of these apply for squares. A square is basically a parallelogram. So the opposite sides are parallel, everything. That's both a rectangle and a rhombus. So it has 4 right angles, 4 congruent sides. To prove something's a square, you just need to first prove it's a parallelogram, then prove it's a rectangle, then prove that it's a rhombus. Okay, let's go ahead and go over to our next type of shape. The next shape that we learned about were trapezoids. So remember, a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. This is important because since it's exactly 1 pair, it is not a parallelogram. So notice that it's not in the box of parallelograms. It's still a quadrilateral, but it is not a parallelogram because it doesn't have opposite sides congruent. In a trapezoid, the sides that are parallel are called the bases. The sides that are not parallel are called the legs. There's one special thing we know about trapezoids. The mid-segment of the trapezoid is the average of the lengths of the bases. So remember, the mid-segment is this segment that connects the midpoints of the legs, and the length of that segment is the average of the lengths of the legs. There's one special type of trapezoid called an isosceles trapezoid. An isosceles trapezoid is a trapezoid that has the legs congruent. So it has all the properties of trapezoids, so it has exactly 1 pair of parallel sides, but it also has legs congruent. It has base angles congruent. It has diagonals congruent. And as long as 1 pair of base angles is congruent, you can prove that it's a trapezoid. So in order to prove that, an isosceles trapezoid. In order to prove that a trapezoid is isosceles, what you could do on the coordinate plane to check if the legs are congruent is use distance formula. You would find the length of each leg and see if it's the same. In order to prove that it's an isosceles trapezoid by showing the diagonals are congruent, you would use distance formula on the diagonals to see if the diagonals have the same length. If they do, you know that it's an isosceles trapezoid. So up here, to show that there's exactly 1 pair of parallel sides, what you would do is use slope formula to show that exactly 1 pair of sides has the same slope, the other pair of sides does not have the same slope. Okay, last but not least, we had kites that we learned about. A kite is a different type of quadrilateral. It's neither a parallelogram nor a trapezoid. A kite is a quadrilateral that has exactly 2 pairs of consecutive congruent sides. So kites, they look like something like this, and the sides would look like that. Okay, here are some properties that we know about kites. We know that the diagonals are perpendicular. And we know that exactly one pair of opposite angles is congruent. That would be the angles between the non-congruent sides. In order to prove that a quadrilateral is a kite on a coordinate plane, you would want to show that exactly two pairs of consecutive sides are congruent. In order to show sides congruent, you would use distance formula. Okay, so there are all of our types of quadrilaterals. Now the last thing that I wanted to do are go through your formulas quickly with you. So slope formula, remember, is equal to the rise over run. So it's the change in y over the change in x. You could use y2 minus y1 over x2 minus x1, or you can use y1 minus y2 over x1 minus x2. Okay, next let's do distance formula. Distance formula, remember, you can always use Pythagorean theorem instead. It's basically the same thing. What you're doing is you're taking the difference in the x's and squaring it, plus the difference in the y's and squaring that, adding them together. And since you don't want the distance or the length squared, you have to square root both sides. It doesn't matter what order you do your x's or your y's, the subtraction. Since you're squaring it, it will always end up positive anyways. Okay, so that's distance formula, and remember, you could always use Pythagorean theorem. So that's the sum of the legs squared is equal to the hypotenuse squared. Next is midpoint theorem. The midpoint of a segment is at the point the average of the x's. So you add up the x's and divide by 2. And the y value is the average of the y's, so you add up the y values and divide by 2. It doesn't matter what order you add your x's or y's, so you could also do x2 plus x1. It doesn't matter. Just make sure that you're keeping your x's together and your y's together. And then simplifying. Okay, let's see, were there any other formulas that we needed to talk about? I think that's all. Okay, one more quick reminder on slope. If two segments have the same slope, they're parallel. Opposite reciprocal slopes means perpendicular. So opposite reciprocal, that's like 3 and -1/3, for example. All right, I think that's about everything you need to know for quadrilaterals. Study this, write it down in your notes, make sure you know it. If there's anything I missed, let me know. Have a great time studying. I'll talk to you soon. Bye.